So we've looked at equations where there are infinite solutions. And just as a review, we have infinite solutions where we have two equations that are essentially the same. For example, I have 2x plus y is equal to 2, and the second equation is 4x plus 2y is equal to 4. Now, if I divide everything in the second equation by 2, I end up getting 2x plus y is equal to 2 as well, which is the exact same as our first equation. So this is a case where we can't find an exact solution, like x is equal to 5 and y is equal to 6. However, we can find a general form for the solution. For example, we might be able to find a relationship between the two solutions, such as, is the x solution always half of the y solution, or is the x solution always half of the y solution plus 5? Either way, we can find a relationship between the solutions. So since these two equations are the same, I'm just going to get rid of the second one. And it might sound a bit counterintuitive that when you have only one equation and two variables, the only way to solve this is to introduce another variable. And that's what we're going to do here. And by convention, we can use the Greek letter lambda, which looks like this. But any variable works. So what I'm going to do is I'm going to let either x or y equal to lambda. Either one is fine. I'm just going to pick y in this case. And I'm also going to specify that lambda, or your variable, is an element of R, or all real numbers. And that basically just tells you that this y value can be any real number. So integers, whole numbers, pretty much anything except for imaginary numbers, which aren't covered in this course anyways. Now let's rewrite the first equation using our new variable. So that's just 2x plus lambda is equal to 2. And then we are going to rearrange for x. So moving 2 to the other side, we get this. And then dividing everything by 2, we get this. So now we know what x is equal to in terms of lambda. And what about y? Well, we actually specified that at the beginning, y is just equal to lambda. And therefore, if we wanted to come up with a solution in terms of a coordinate form, our coordinate would be our x value followed by our y value. So bracket 2 minus lambda over 2, that was our x solution, and comma lambda, which is our y solution. And this is the general form for our solution. What this means is, for example, if lambda is equal to 1, that means our solution would be 2 minus 1 over 2, comma 1, because we're just subbing in 1 for lambda. And this evaluates to -half and 1. Likewise, if we said lambda was 2, this would be our solution. So basically, since we can't find a unique or exact solution, we have to come up with a general form for any potential solution.